Hello and welcome back. So far we have understood how to build a binary class classifier and how to check whether the model is working good or not. In our particular example, we have taken an imbalanced dataset with 5s and not 5s where there are 3000 odd records belonging to 5s and 33,000 records belonging to not 5s. 10% of the records belong to positive case and 90% of the records belong to negative case. So we called this as a imbalanced dataset, and then we said the accuracy measure is not appropriate. Then we went into the confusion matrix and precision recall and F1 score. To build this model, we have used the SGD classifier class from scikit-learn. The SGD classifier is based out of logistic regression. If we understand the mechanics of logistic regression, we will be able to take control over the model and get whatever precision and recall score we wanted to. Because for some problems, the precision should be high. For some problems, the recall should be high. How to achieve it? We'll see it now. First, let us try to understand what is sigmoid function or logistic regression. The algorithm SGD classifier is based out of logistic regression. So logistic regression takes n number of inputs and a y variable. It's a supervised learning algorithm and it's a classification algorithm. So it takes m number of records and x1 to xn inputs. x0 is bias term. It is 1 for all the records. And you feed it to logistic regression algorithm and it learns the hypothesis function. The hypothesis function for logistic regression is 1 by 1 plus e power minus theta 0 plus theta 1 x1 plus and so on theta n xn. Nothing but 1 by 1 plus e power linear combination of all inputs. We have taken 1 by 1 plus e power linear combination of all inputs because we have to generate a number between 0 and 1. Because in this binary class classification problem, the y variable is either true or false, either 1 or 0. In regression setup, we need to generate a number which is between minus infinity and plus infinity. But in classification problem, we need to generate a number either 0 or 1. Instead of generating a number, the logistic regression algorithm will generate a number between 0 and 1. We can consider that as a probability. If the number is close to 0, we say the record belongs to 0. The number is close to 1, we say the record belongs to 1. So we take a threshold. Generally, logistic regression algorithm takes 0.5 as the threshold. If the outcome of this hypothesis function is greater than or equal to 0.5, it says the record belongs to 1. If the outcome of this logistic regression function, the sigmoid function we call it as, is less than 0.5, we say the record belongs to 0. So the algorithm learns the weights, the thetas. When you pass m number of records to the algorithm in multiple epochs, we use gradient descent algorithm here also, and we'll see how exactly the gradient descent algorithm learns in coming classes. But in couple of epochs, maybe 50 or 100 epochs, it learns these thetas, these coefficients it learns in such a way that all the records belonging to 1, the outcome of the hypothesis function is going to be greater than or equal to 0.5. And for all the records which are equal to 0, the y value is equal to 0. For those records, it will generate a number less than 0.5. So that is learning. So logistic regression algorithms learning is nothing but learning these thetas in such a way that for the records belonging to 1, the outcome of the hypothesis function is going to be greater than or equal to 0.5. For the records belonging to 0, the outcome of the logistic regression function is going to be less than 0.5. The logistic regression algorithm, by looking at this data, the input and output, it learns it. So in the, when you pass a new record, it will actually try to generate that probability. If it generates a probability greater than or equal to 0.5, we say the new record belongs to 1. If it generates a probability less than 0.5, we say the record belongs to 0 or false. So in coming class, we'll try to understand more mechanics about this sigmoid function. Thank you.